Well, now here's the follow-up to our experiment with the potassium chlorate. I have written the chemical reaction up on the board. You've seen that already. What I would like to do at this point is give you a little bit of time so that you can write the information that I have on the whiteboard. I'm going to begin, though, with something that we typically have to do. In any type of stoichiometry, one of the first things you have to do is make sure your chemical formulas are correct. So to use the chart of ions, that would help. Anytime I have a diatomic gas like oxygen, I always know that it's O2. And my potassium chloride, potassium has a +1 charge, the chloride's a -1. They're going to come together in a 1-to-1 proportion. If you do the crisscross, you would spot that also. So I have to have a set of formulas that are correct. The second thing I want to do is I want to balance the equation. So let me do that for you. I look at the coefficient, the subscripts here. There's a 2 on the oxygen here. There's a 3 on this oxygen here. So I'm going to save some time. I'm just going to switch the numbers. I'm going to make this a 2, and I'm going to make this a 3. Since I have 2 potassiums and 2 chlorides on this side, I better put a 2 in front of the KCl to get those to match up. So my ratio for my reaction is 2 potassium chlorate will give 3 oxygen and 2 potassium chloride. Let me stop for a moment now and give you a chance to copy that down. 2 potassium chlorate yields 3 oxygen and 2 potassium chloride. The next portion I'd like you to put into your notes is this little section right here. Let's imagine we're trying to make some lunch and we're going to make a sandwich. And to make my sandwich, I'm going to need, or I'm going to want, 2 slices of bread. I'm going to put 4 slices of lunch meat in the sandwich, and then 2 slices of cheese. This together will give me the one sandwich that I'm preparing. If I abbreviate that, it's going to look like this. 2 of bread, 4 of lunch meat, LM, and 2 of C, or 2 cheese, put together, and maybe I add some toppings and stuff like that, but put together that will give me one sandwich. So I'll give you a chance to copy that. Now, if I was working in the dining hall here at school, maybe for a given lunch period, I'm going to need to have prepared 60 sandwiches. So let me put that on the whiteboard. And I want to figure out how much bread am I going to need, how much lunch meat, how much cheese. Well, if I compare these two, this is 1, this is 60, I'm going to need 60 times everything that I have for my ingredients. So 60 times 2 would be 120 slices of bread. For the lunch meat, I have 4 times 60, or 240 slices of lunch meat, LM. And finally, 2 times 60, or 120 slices of cheese. That will give me my 60 sandwiches. And if you think about it, the people in the dining hall, in the kitchen, they have to think this way all the time, knowing how much of each ingredient they're going to put together. Well, in effect, what the chemist does is the same thing, called stoichiometry. You have to figure out how much of a reactant you're going to be needing to make so much product, or even vice versa. If you have so much product, how much reactant did it come from? Now, suppose I only had 60 pieces of bread and I still wanted to make sandwiches. Comparing the 120 and the 60, I have half of the amount of bread that I need, which means that everything else will be half the amount. And when I'm done, I will have half of the 60 or 30 sandwiches. So let me put that over here. And let's see how much of these things we have. Well, if I have 240 slices of lunch meat and I only need half of them, then I'm going to have 120 left over, or excess. I only need 120 of lunch meat. And then think for yourself, how much cheese do I need? I need half of the 120, or 60 slices of cheese. And when I put this combination together, 60 bread, 120 lunch meat, I'll get 30 sandwiches. So the proportioning works very nicely, and it shows to me that when I have certain amounts of reactant materials that I put together, then I can produce a certain amount of product. And that's important to the chemist, and it's actually important to all of us because of the things that we buy as consumers. They have to be made in the right proportion of ingredients. Now, I want to briefly turn off the video here and set up for the calculation of the chemical equation up here for the stoichiometry. So let me turn this off. So now we want to do the calculation for the stoichiometry reaction. At the top of my chemical reaction, I've added the words known and unknown because I knew that I weighed out 3 grams. I'm going to try to figure out what's the mass of potassium chloride. The type of problem that I'm doing for the stoichiometry here is a mass to mass problem. I can do all kinds of problems. I can do mass to volume, mole to mass, volume to mole. This one, which we're starting out with, I want to make it very clear and very simple. It's just a mass to mass problem, and it fits in with the demonstration I showed you. And here's a general equation that I can use to solve that. And this would be good to copy down. First thing I want to put down is my known mass. In effect, I put this over 1 understood, so I just have it blanked on here. Then I convert this to a certain quantity of moles. So I have 1 mole of the known over the molar mass of the known. The second part that I need, I've got to go up to my chemical equation, look at my coefficients, till I see how the mole quantities compare to one another. And I'll put numbers in here in just a moment. And then the final step, I'm going to look up the molar mass of my unknown substance. I'm going to use the periodic table for that. And I put that over 1 mole of the unknown substance. So let me back up a little bit here so you guys get a chance to copy all of that. This is the bulk of what you're copying right now. Okay, and I'm going to put some numbers in now. For my known mass, that's the potassium chlorate, I'm going to list 3 grams. KCLO3. That's my known. Next, I'm going to put 1 mole of the KClO3 over its molar mass. In order to get that, I have to go to the periodic table, look at my symbols, look at the subscripts, get the masses, and figure out the total mass of that. And that's what I've done here. I'm going to hold this up so you get a chance to see it. And if you don't get all of this copied, you can actually calculate it out. I have 1 times potassium, 1 times chlorine, 3 times oxygen. I multiply those by their masses from the periodic table. And then I get their quantity by way of mass for each of the components. The final step, 3rd column, I add all of them up. I got 122.548. And you can go back and look at the video if you didn't get all these numbers. 122.548. I'll put that in down here. Grams, KCLO3. My next step is to figure out what's the comparison of moles that I have. So my unknown is the KCl. I have 2 moles of that. So I'll put 2 mole KCl here. I go over to this side of the equation. The balanced equation shows that I have 2 moles of potassium chlorate. So I'll come back here and put 2 moles KClO3. And the last step that I got to do is figure out the molar mass of KCl. And I've done that already. Then let me show you that number. I'll hold this up again. Again, if you can't get everything copied, just figure it out for yourself or go back and watch the video some more. 1 times potassium, 2 times chlorine. When you get those masses and multiply on through, take that third column and add it up. That'll give you the molar mass. And here we got 74.551 grams per mole. Let me put that aside. Let me put that into my number. 74.551 grams KCl. Put that over 1 mole KCl. There's my entire equation. Let me tilt that a little bit for you. And here's where the factor label process or dimensional analysis, here's where that comes into play, and it's very handy. I'm going to look at my units. Here I have grams of KClO3. Down here I have grams of KClO3. Those units are the same. One's in the numerator, one's in the denominator. I'll cancel out the unit. The number stays, I just cancel out the unit. I have 1 mole of KClO3 up here. I have 2 moles of KClO3 down here. I'll cancel out the mole KClO3 label. I leave the 1 and the 2. Let's go to the last one here. I have moles of KCl over moles of KCl. They will cancel. And at this point, you can see I got 2 over 2. You can reduce that to 1 over 1 or just 1. So let me do that. Makes the math a little easier. And all the units have canceled out except that last one over here, the grams of KCl. And that's what we were looking for. That's what we want to calculate. So what you have to do, and I want you to do this on your own, is multiply all the top and divide by the bottom. So I will end up with 3 times 74.551. Whatever that number is, I'll divide it by 122.548, and that'll give me my mole, my gram quantity. I'm going to turn this off for a second now. Again, if you didn't catch everything, just go back and watch the video a second time. The final part of the setup that I want to show you is how we can break the problem into segments or sections. Some of you may not be using time signs up here. Some of you may be using vertical line, but they both work the same. The first thing that I want to show you is this much of the question or the calculation is what we call a mass to mole conversion. That's the first part. The middle part is where you compare the coefficients from your balanced equation. For us it's 2 and 2. That part is called the mole ratio. That's easy to get right off the balanced equation. The last part is called the mole to mass conversion, and when you do that part, you're finally going to get your quantity in grams for the final solution to the problem. So that gives you a little idea how you can set these up and solve them. And you could use this as a model for other kinds of equations. I'll stop here.